Hi guys, this is Mr. Ho here. This video is going to be the part 2 of our Typhoon class. So if you haven't checked out the previous video, please go to look at that video. Now in this part, we are basically going to go through some of the practice questions regarding the oxidizing property of acids. So my advice is, if you have time, if you have your notes, please go through the question yourself, or at least try to think of the answer before looking at the later part of the video. Because I'm basically going to talk about the answers, and it would be best if you have at least go through it yourself once, right? Now again, if you have your notes, obviously you can take out your notes and go to page 24. But if you don't have your notes at your hand, don't worry. You can always download the part of the notes. I should have attached a link to part of my notes from the description below. So make sure you have downloaded that one if you haven't got the notes already. And again, try to go through it first before you look at the answer. All right? So let's get started. Let's look at the questions. So first of all, it says that some copper turnings, so basically some copper solid, are added into a test tube containing hot concentrated sulfuric acid. Now, write a chemical equation for the reaction. So you know that for hot concentrated sulfuric acid, it is an oxidizing agent. So it is not a simple metal and acid reaction. It should be an oxidation where, first of all, sulfur dioxide will be formed, and it also have water. Now as the product, you can either put down copper 2 oxide or copper 2 sulfate. I myself prefer copper 2 oxide because with so few water, there should not be a lot of copper 2 sulfate formed, and second of all, no need to balance, right? It is already balanced, if you can tell. Now for B, state 2 observable change of this reaction. So first of all, it is the copper. So copper, we said it is a reddish brown solid. So obviously it dissolves. Okay. And secondly, is about the copper 2 oxide. Because this one is a black solid and it does not dissolve in water, plus the fact that there is very few water, so we say that black solid forms or suspends in the solution. Now you can also, you may think that, oh, SO2 is being produced, so should I write down colorless bubble produced? Not a good idea, because first of all, the acid is being heated to boiling, so probably you cannot identify whether the bubble is due to the boiling or the production of SO2. Alright, so I don't think that would be the case. But you can also say that because still some copper 2 sulfate will form, which dissolves in that very tiny bit of water, so the solution will probably have a color change. So you may also say that the solution changes from colorless to pale blue. Okay. Now for part C, state and explain the observable change, if any, if the following is put near the mouth of the test tube. So we are basically testing the sulfur dioxide gas produced. Now first we put a moist blue litmus paper. Obviously the paper changes from blue to red. Okay. Now this is because the sulfur dioxide gas produced dissolves in the water of the litmus paper. That's why you have to moist it. You have to allow the gas to dissolve first. Dissolve in the water of the litmus paper and form sulfurous acid. H2SO3. Okay, sulfurous acid. Now bear in mind it's not sulfuric acid because you need sulfur trioxide to form sulfuric acid. For sulfur dioxide, it only forms sulfurous acid. And if we have sufficient oxygen or if we have an oxidizing agent, then the sulfurous acid can oxidize into sulfuric acid. But I think this is not the case. You may also include a chemical equation. SO2 dissolves in water to form H2SO3 to substantiate your explanation. Remember, in chemistry, sometimes you can include chemical equation as part of your explanation. And if your explanation is not suffice, but that equation can help you to cover the part that you haven't mentioned, then the invigilator will still award you marks. Okay. Now C2. What if we have a potassium dichromate solution? I mean, a filter paper soaked with potassium dichromate solution. Now, you guys know that this is a very common oxidizing agent. And when an oxidizing agent like this come across with a reducing agent like this, SO2, then there should be a chemical reaction. Remember, SO2 is not only an acidic gas, but it's also a reducing agent. Now, so we say that the paper changes from orange to green. So if you're trying to explain, so first of all, you have to say that SO2 is a reducing agent. And because we have to account for the color change, so we'll say that the SO2 reduce the Cr2O72-. Remember, this is not the whole potassium dichromate that undergoes reduction. It is only the dichromic ion that undergoes reduction. So it reduces this dichromic ion to the chromium 3 ion, which is green in color. Okay. You may also put down a chemical equation to substantiate your answer, but I understand that this time is quite difficult to write. But if you wish, I can still help you. So we will put down SO2 react with Cr2O72- to form SO42-. It will form sulfate ion. If you're not sure, you can check for the previous part regarding the common reducing agents. For chromium, it must form chromium 3+. Okay. Now, to balance this equation, I try to go for the fast method. So hold on a second. 正六正六正三六粒電子，正四正六兩粒電子，六二六二三 ，oxygen 6加7 13 13 12 13 12。Okay, that should balance the equation. Now, if we replace the concentrated sulfuric acid by the diluted one, stay and explain the difference in observable change. So first of all, we say that no observable change. Okay, for the reaction with dilute H2SO4. Okay. Now don't just say no observable change, because otherwise people would think that, oh, does it mean that the dilute acid and the concentrated acid react the same way, so there is no change in the observation? Like you try to convey your message to avoid confusion, right? So this is why I put down the later part. You try to mention the fact that dilute sulfuric acid is not an oxidizing agent. So you will say that dilute sulfuric acid is not oxidizing, while concentrated sulfuric acid is oxidizing. Okay. Again, this question is requiring a comparative sense. So that means when you answer this question, you have to mention both the diluted sulfuric acid and the concentrated sulfuric acid. Okay? So it shouldn't be too difficult. Now I'll move on to the next question, next practice question. In this case, we have a zinc button added into 3 different kinds of nitric acid with different concentration. As you can see, 0.12 mol per dm cube, 1.2, and 12. Now, it's pretty obvious that these 3 concentrations represent the 3 different situations, right? The very diluted one, the diluted one, and the concentrated one. Plus the fact that you can see the 3 solution gives different observable change. Okay. Now, for part A, you are going to put down the chemical equation for the 3 reactions that taken place. Shouldn't be that difficult. For part A, this is the very diluted one, so the very diluted one, this is diluted one, and this is the concentrated one, basically. So for the very diluted one, it does not have the oxidizing property, so this is basically a metal and acid reaction. So zinc react with HNO3 to form zinc nitrate and H2 gas. Put a 2 here to balance. This is like the form 4 when we talk about metals. You still remember? Now for flask B, it's a diluted one, so not only does it produce the zinc nitrate, but it also produces nitrogen monoxide plus H2O. Okay? No more hydrogen gas. So to balance this equation, it's probably quite challenging if you haven't kind of memorized the stoichiometry. Now, in fact, I won't ask you guys to spend time exclusively to memorize the stoichiometry. But what I try to say is, with more practice, if you keep encountering questions like this, you kind of automatically pick up those mole ratios. Like me, I have done this many times. So for me, I don't really have to balance it because in my head, I already know that it's gonna be 3, 8, and then 3, 2, 4, I guess. Right. So I hope you guys can do this. Like what I did after some practice, I guess. Now for flask C, it's going to be the concentrated one. So the only difference is that it produced nitrogen dioxide right away. So it still produced the zinc nitrate, but this time NO2 plus water. Okay? So to balance this equation, we need, I think it's 4 nitric acid, and then 2 NO2, and then that's it. Okay? Now for part B, explain the difference in the reaction occurring in flask A and flask B. First of all, I need to clarify one thing. Now, even though we say that for flask A, the very dilute nitric acid does not have an oxidizing property. But if you check out the equation, it is still a redox reaction, Zinc is oxidized to zinc 2+, but you notice that it has nothing to do with the NO3-. Instead, H+ is reduced to H2. So even though nitric acid, very diluted one, is not an oxidizing agent, the reaction itself is still a redox reaction. Now, but of course, the only difference is the oxidizing agents. This one is H+, this one is actually the NO3-. So the NO3- is reduced to NO. So that is the difference. So when you answer this question, we talk about it one by one. We said that in flask A, we say the very dilute nitric acid is not oxidizing, so no NO is produced. However, for the flask B, which is the dilute nitric acid, it is an oxidizing agent. So we say that the NO3- is reduced to NO. Alright? So that tells the difference in terms of the reaction. It does not necessarily have to mention the difference in observation because the question is simply the difference in reaction. It's not the difference in observation. Right? Alright, in part C, it says that for flask B, the dilute nitric acid one, it said that there is some pale brown gas observed towards at the mouth of the container. Why is that? This is obviously because of the nitrogen monoxide is further oxidized by the atmospheric oxygen to form the brown nitrogen dioxide. So that is going to be the chemical equation involved. Okay. Now for part D, an evaluation type question, it is simply asking if we are going to make zinc nitrate, we want to prepare zinc nitrate, which reaction are we going to choose and why is that? Now in this case, I think most of you would choose flask A, right? So flask A is the one that you are going for with a very dilute nitric acid, because whenever we come across this question, like evaluating a reaction, we look at first of all safety, and second is the yield, is the percentage yield, and then maybe the difficulty of the experiment itself. Now regarding safety, obviously we would choose flask A because flask B and flask C will also produce toxic nitrogen dioxide. Okay, flask C is straight away nitrogen dioxide, but flask B, even though it takes an extra step to produce NO2, is still toxic. So we say that no toxic NO2 gas will be produced. This is related to the safety. Okay? And the second one is talking about the yield, of course. The yield. If you look at the top here, if you want to produce zinc nitrate and you look at the nitric acid, now we look at the mole ratio, like how many moles of nitric acid is required to produce 1 mole of zinc nitrate. Now you look at the ratio. This is 2 to 1, 8 to 3, 4 to 1. So obviously the first one is the most efficient, effective when it comes to converting nitric acid into our desired product. Others are not so efficient, meaning that a lot of side product is produced. So to answer this one, you can say that because it requires the least amount of HNO3 to produce the same amount of zinc nitrate. Okay? It requires the least amount of nitric acid to produce the same amount of zinc nitrate. Very simple explanation. You can also say that because you may ask, right? We have a conservation of atoms. If the ratio is so low, that means there will be a lot of side products. For example, like this, the nitric acid is that the nitrogen part is not entirely becomes our desired product. It also forms nitrogen monoxide, right? So that means a lot of side products. So you can also say that it has least side product. Or if you later on study green chemistry in Form 6, you can also say that it has the highest atom economy. Okay? Atom economy is basically how efficient, how effective you are when you are manipulating the atoms of your reactant. So the most ideal case is all of the atoms from a reactant ends up as your product. So you don't waste any atom because you don't produce any side product. So that will be 100% atom economy. So the lower the atom economy means the more atoms are being wasted. That implies more side products. Okay? So these are the two major reason for that. You may also discuss, but I only talk about it. You only discuss the feasibility, like the experimental procedures. Because you think about it, if you're going to prepare this one, you are going to use usually excess zinc and limited amount of nitric acid. Why? Because later on you are going to filter off unreacted solid, which is easier than to remove unreacted nitric acid. So we will go for excess amount of zinc solid. However, you think about it, for dilute nitric acid or even concentrated nitric acid, if you want to use limited amount, so that basically means small volume. That means small amount of water. And if you want to produce zinc nitrate, then it will very likely to produce a saturated solution. And with the saturated solution, that means you have part of your product undissolved together with then you basically again difficult to separate. If you are producing a saturated solution, that means you have some solid product together with your unreacted zinc, and when you do your filtration, you basically remove part of your product, resulting in a very low percentage yield. So this is more like a practical consideration, but may not be the best one to answer this question because quite difficult for you to write it down. Okay, so bear in mind for this evaluation type question, we look at safety, we look at the yield. That should be enough to answer most of the questions. Okay, so that's it for the Typhoon video class. Hope you guys have learned something, and that's it. Goodbye.